Good morning. On behalf of Gasunie, I would like to welcome you on this webinar on hydrogen infrastructure. My name is Gerard van Peijkeren and I will be the moderator for today. We will be doing this webinar in English because we have also quite a lot of international guests. And although that might sometimes be a little bit difficult in looking for words, but I think that we can all manage that. Let's start with an introduction of myself. My name is Gerard van Peijkeren, as I just mentioned. And within Gasunie, I am responsible for Gasunie New Energy, which is the part of Gasunie which is working on the renewable and sustainable projects. To give just a few examples, as you can also see on this slide, we're working on hydrogen, we're working on green gas, we're working on carbon capture and storage, and we're working on heat transmission. And that's also in line with the ambition that Gasunie has towards 2030. Because if you look at the Gasunie strategy and Gasunie philosophy towards 2030, we want to be an important player in the energy transition, and we want to make a conversion from natural gas towards a renewable energy infrastructure company in 2030 and far beyond. And Gasunie is in transition, and that's also why we are currently working on this project. As I mentioned, one of the subjects that we are currently working on is hydrogen. And hydrogen is going to be an important part of the renewable energy system of the future. If we look at the global, European and national climate goals and the ambitious goals that we have, we know and we have learned already that we cannot do that alone with renewable electricity. We know that hydrogen is an essential energy carrier to realize carbon neutrality in 2050. Not only because it is more easy to transport, not only because it's more easy to store, to supply the flexibility, as we will all also further on here this morning, but also because some of the sectors cannot just use the renewable electricity. We are working with Gasunie towards a total system in the future where hydrogen will play an important role. And that's also the reason why we have this session this morning. Normally, during normal circumstances, without the corona, we would make a round trip through the country. We would visit all the different companies and we would have discussions with them. But as an alternative now, we have started this webinar. But in the end, it's mainly about not only telling you what we want to do, but it's also about hearing from you. And at the end of this webinar, we will also then come back to you and we will have a questionnaire, and we hope that we can start after this webinar with a, let's say, very interactive process with all of you as audience. What's the purpose of today? Maybe I should go just back to this slide. As I mentioned, we will tell you about hydrogen, we will tell you about our developments, we will tell you about our projects. We will do that in two phases. One is about the backbone, one is about our storage facility, and we will tell you where we are and what our plans for the near future are. And as just mentioned, we would like to get back from you the knowledge and the information that we need for the further development. 2 days ago, we also had a webinar, which was on Highway 27, and that was mainly aiming at the more political and regulatory side of the development of hydrogen. Today, it's more about the technical and, let's say, the commercial part of hydrogen and the future developments of hydrogen. Who are in this webinar? As I mentioned already, some of the audience is international. We didn't put that in this one. You can see that only in the lower graph with part of the other. But there are different areas: customers, producers, authorities, policymakers, and other people. Quite some producers. And we also see that the different industrial areas are present. The IJmuiden Amsterdam area, Rijnmond, the northern part of the Netherlands, the southern part of the Netherlands, Limburg and Zeeland. And those clusters, those industry clusters, are very important in the development. And what we will see with the backbone is that the backbone will be aiming at connecting these clusters, but in the presentations further on, that will be part of the topic. There are also some house rules. All audience will be muted by default, so it's not possible to say anything from the audience or to ask questions by speaking. Please use a headset or earplugs. You can read it on this slide to get the best sound. But what's a very important one also is please enter questions in the chat box. There is a chat box available, and we will try to address them partly at the end of each presentation, partly at the end of this session. But certainly all the questions will be answered after the session via a Q&A that we will share with you. Let's go to the program of today. As I mentioned, the agenda for today is consisting from two parts. One is about the hydrogen backbone. One is about hydrogen storage. And both parts will consist from three presentations. A kind of general overview, technical information, and commercial information. Between the two sets of presentations, we will have a short 10-minute break. And at the end of the presentations, we will have a wrap-up. I think we could go to the first presentation now. And the first presentation will be given by Harry Smit, who is project manager of the hydrogen backbone. And he will share with us some information about the hydrogen backbone. Harry, please, the floor is yours.
Am I clear to hear? Okay. Thank you, Gerard, for introducing me. My name is Harry Smit, as Gerard mentioned, and I'm working on the hydrogen backbone project as a project manager since roughly a year now. I will present to you a general overview on the hydrogen backbone, how we as Gasunie expect this backbone can develop in the coming 5 to 10 years. For this reason, we made a beautiful map. You could look at it as a weather map, but it's not. But if you're looking from the top, well, it looks like the skies are bright and the future is bright if all this can happen as we intend to realize in the future. This map shows a future hydrogen backbone network that is mainly to be developed from existing natural gas pipelines. These are the yellow lines in the graph. Partly we have to build new pipelines. These are the blue lines in the graph. We expect this network to develop in the coming 5 to 10 years. But in fact, as of today, we already have a pipeline, former natural gas pipeline, operational for hydrogen. And this is the pipeline that is located in Zeeland between Douw and Yara. And this has been in operation already for a few years. This is also more or less a statement that with natural gas pipelines, we can transport hydrogen through natural gas pipelines in a safe manner. What we foresee in the coming 5 to 10 years is that first developments will take place in the 5 clusters. The 5 regional industry clusters that we have in the Netherlands, Zeeland, Rotterdam area, Amsterdam area, the north of the Netherlands and the Limburg area. We can build the infrastructure that can connect these clusters, say roughly in the period between 2025 and 2030. We foresee, or we already experience, that first activities or first projects are already taking place within the Rotterdam area, for instance, where there is expected to come onshore electricity from wind on shore. That could be through electrolysis set set into hydrogen, and this gives already the opportunity to have hydrogen available in this area as of maybe 2024. We see the same developments in the north of the Netherlands, where there are several projects more or less getting to start. And these projects are, for us, the incentive to start to make infrastructure available that can connect the projects in the north. One more thing I forgot to mention. You might say, how is it possible that Gasunie can make these pipelines available just out of a sudden? But that's not the case. The fact is that Groningen production will reduce in the coming 10 years, and Groningen export capacity will reduce severely in the coming 10 years. And this this makes it possible to make pipelines available that are presently natural gas pipelines, and that can be repurposed to hydrogen pipelines. Back to my storyline on the industries and on the different regions. I just mentioned we can connect, we see already activities in the different regions. We think these regional pipeline systems can develop in the coming 5 years, maybe until 2026. And in this time frame, we can develop this regional pipeline system. Once these regions develop, and once supply and demand of hydrogen really takes place in this region, there will be incentive for us to connect all these regions and to build, in fact, the network that is envisaged. After connecting the industrial regions, or maybe more simultaneously, we can also connect cross-border industrial regions in Germany and in Belgium. For instance, the Hamburg-Bremen area, for instance, the Ruhr area, and for instance, the Antwerp-Ghent area. We expect that these connections, these cross-border connections, where the system of Gasunie will end at the border, will be possible to have these developed in a period of roughly 2028 to 2030. Of course, this is based on the infrastructure outlook that we see. It should also be in parallel with developments in these different industrial regions. A small wrap-up. One more thing I like to mention: these pipelines are natural gas pipelines, and these are, as of its nature, huge pipelines that create a lot of capacity, because they were simply meant for high natural gas pipeline capacities. And with hydrogen, we expect, we can create the same capacities in the coming years. Small wrap-up on what I just mentioned here. The infrastructure will be built up largely from existing natural gas pipelines. The capacity we can create, even without compression, will be about 10 to 15 gigawatts. For relatively low costs, we can create high transportation capacities. The usage will have to grow from the start, say roughly 2025, over a period of 10 to 15 years. We foresee the costs of these investments will be roughly, or the total investments will be roughly 1.5 to 2 billion euros, which means that due to the very low initial startup contracts or startup capacities, this would have to be go parallel with government funding to make it financially viable for Gasunie. But in the end, we expect, it's our intention to have commercial contracts in place that can make the cost, that can recover the total costs in the end. What we need from you is information on how we can build this infrastructure, what starting points we should use for building this infrastructure. Since we have our physical constraints within the infrastructure and you have your market requirements as potential industries, off-takers and producers, we will have to come to the bandwidth of specifications on capacity, but also on pressure and also on quality. So in order to fulfill all the customer needs, we have set up this way of working for building this natural gas pipeline system in advance before the market really can grow to a future hydrogen market. And with the intention to keep tariffs for transportation low and to be only a minor part of the hydrogen cost chain. This is what I want to tell you about a general view on the hydrogen backbone. Maybe there are questions, I don't know.
Thank you, Harry, for giving this overview of the major backbone plans. There were a few questions already from the audience. One of the questions that was asked many times already is, are the slides available? Yes, the slides are available for the audience. We will send you an email after these presentations where you can find the presentations that are shown today, but also where there is a link to the questionnaire that we would like you to fill in and to help us further. A few other questions, Harry, that were asked, and you mentioned part of it already, but our neighboring network operators were very anxious to know. In the graph of the backbone network, it appears that the Gasunie network or the hydrogen network is crossing the borders towards the other countries. Is Gasunie planning to do that development themselves, or can you say something about that?
Well, as you can see over here, Gasunie crossing borders in energy. You can also look at it as more artistic freedom of the person who made the graph. But what is meant really is that we will have this backbone until the border points that are presently in place for the gas system. Maybe only for Gasunie Germany. If Gasunie Germany will also have pipelines in place in future for hydrogen transport, then we will cross the border, but of course as a separate country being under the Gasunie umbrella.
So only there where Gasunie isn't currently having pipelines.
Correct. We will stick to the GTS network.
The second question that was asked was that it seems that the new hydrogen pipeline is aiming at relatively pure hydrogen, and we will learn, I think, more about it in later presentations. But what do customers that still want to use natural gas, are there still possibilities? Can people have connections to both? Can industries blend hydrogen and natural gas if required?
As you stated, that's right. The hydrogen network will connect to industries, but especially in the beginning, these connections will be parallel to existing natural gas connections. So that gives companies the opportunity to have a low start in using hydrogen and blend it away with the natural gas streams, for instance. Of course, it's fully up to them how they want to use it.
And another thing that you mentioned is that the backbone is mainly aiming at connecting the 5 industrial areas that we have, the major industrial areas. What about customers that are not directly in that areas but are a little bit further away from our pipeline system? Can you say something about your thoughts about how they can be connected and when that might happen?
We did think of it, and we do see, of course, the difficulty in first reaching only the main industrial clusters in the Netherlands. But that's simply a matter of a fact, because on a short term we can make pipelines available that are directed to these 5 industrial regions, and there will be industries that are further away from the national backbone, and it will take more time to reach these industries. But I can say there is a kind of solution, or a solution will be developed, has to be developed, and that is possible by using certificates for hydrogen as green CO2 neutral gas, and by buying certificates, a user of natural gas can in fact virtually use hydrogen. This is still under development, but it's part of the whole plan.
Okay. Harry, thank you very much for answering these questions. We will go to the second presentation of today. The second presentation is more about the technical part of the hydrogen backbone. This presentation will be given by Ronald Pieters. And Ronald Pieters is Technical Project Manager of the backbone. Please, Ronald, the floor is yours. You can give your part of the presentation.
Gerard, thank you very much for introducing me. Yes, my name is Ronald Pieters. I'm working as a Technical Project Manager for the hydrogen backbone and investigating the technical feasibility of the system. There are two issues I would like to discuss with you, two technical considerations. Considerations that are key in development of the technical system, and they are about the pressure regime of the system and the hydrogen quality specification, as mentioned by Harry before as well. To start with the pressure regime, well, what do we mean with that? For operating our hydrogen system, we do need a pressure regime. We need that in order to provide suppliers a pressure to feed their hydrogen into the system. We need that regime in order to give customers certainty about a minimum pressure they will receive. And for our own transmission system, we do need a certain pressure in order to create sufficient transmission capacity. The pressure regime is stated in two levels, an upper level and a lower level. Upper level meaning the maximum pressure, mostly the pressure producers have to feed, and at the lower level, typically the minimum pressure that customers will receive at their connection point. Well, how do we investigate that? Because we're starting from scratch, and we don't have a blueprint as we have in natural gas. So we're investigating, for example, the producers and the consumers and their processes. What do they have in terms of typical pressures if you look at different production methods, but also if you look at different customers and their processes, what do they typically need in terms of pressure? That's on the supply and the demand side, but we also need a pressure regime set for the transmission, meaning we need sufficient pressure drop in order to create the transmission capacity. So these elements were all taken into account into the analysis that we made, resulting in, you could call it a two-step approach for the pressure regime. Our idea is to start with a lower pressure regime, a 10-30 bar, meaning upper level 30 bar and a minimum pressure at a customer of 10 bars. We see that as a starting phase for the first customers that connect to the system. If we see an emerging hydrogen demand, we will need more pressure in the system in order to facilitate the transmission capacity, and that will mean that we will grow to a 30-50 bar system. For the long run, for now, we see a 30-50 bar regime as sufficient for accommodating our scenarios that we see for transportation. However, that's our general idea for the national backbone. It could be focusing on the regional parts that we will develop tailor-made pressure regimes for that region based on the requirements for the customers in that region. For example, if customers would need a higher pressure, higher than 10 bars, it might be the case that we start with a 50-30 bar regime from the start. This is our first concept. As part of the questionnaire, we would like to hear your opinion about this pressure regime. Is it suitable for you? Does it fit your process? We would like to hear your opinion. Another issue, key issue in backbone development is the quality specification for hydrogen. And what do we mean with that? actually two parts. On the one hand, the hydrogen purity, the percentage of hydrogen in our stream, but maybe even more important, the impurities. It will not be possible to transport 100% hydrogen flow due to limitations in production, but also limitations in our transmission system. That means we have to find a specification below but close to 100%. And what we're looking for is actually a system where we have a quality that fits producers and consumers, a quality that's possible in our transmission system, but also a quality that is possible based on the technical options that we see for quality treatment. And if you would translate all these elements into a schematic system, that's actually our idea for a system how we could handle quality in our backbone. What you see, different types of production and different types of consumers. On the production side, could be the case producers have a hydrogen quality that fits with the backbone quality, the so-called pipeline grade in our backbone, and they can immediately feed their flow into the system without any treatment. It could also be the case that a production is a lower purity, and in that case you have to treat the hydrogen before feeding it into our system. Could be, for example, with a PSA installation, a pressure swing absorption installation, where you could purify the hydrogen flow on the supply side. Having said, we would like to develop a pipeline grade. Could be the case that consumers are satisfied with that pipeline grade and they can use it without any modification in their production process or in their application. However, it could also be the case that consumers need to treat the hydrogen flow, for example, for specific impurities. In that case, we could install a safeguard system for specific impurities in order to take them out of the hydrogen flow. Could also be the case that consumers need a higher purity than present in our backbone system. And in that case, it could also be a solution to install local PSA installations in order to treat that hydrogen flow for that specific customer and to provide them the quality they need. Our main question is actually how to find a pipeline grade to supply the larger part of the market without any quality treatment. That would be, or that is our main goal. Of course, we see these technical options, but all these options come at a cost, and we would like to develop a quality spec together with you that's suitable for the larger part of the market without any treatment. Based on analysis we did so far, we actually see 3 specifications that could be suitable for the market, but based on our analysis, and we need your input as well. The specifications are based on purity and impurities. On the sheet, I only mentioned the purity. We're looking at 3 options: 98.0, 99.0, and 99.5. These 3 come with a list of impurities. You can find them in the slide pack that will be online after the webinar. And you can have a look at the full specification that we foresee for hydrogen. In the end, we're looking for for one of these specifications. So we will not handle different specifications, but our aim is to have a single pipeline grade, most suitable or suitable for the larger part of the market. And to reach that goal, to get the best quality specification, we need your input. We would like to ask you, as part of the questionnaire that will be available after the webinar, we'd like to ask you a couple of questions. For example, could you give us your opinion on the 3 specs that we presented? before. Which of these three ones would be best for your process? Could you give us a description of the application that you foresee for hydrogen? Or could you tell us within that application what is the critical impurity or impurities? What are the impurities that you cannot handle and that we should specify in our quality? And do you foresee any quality treatment in your process? Do you see any impurities that you will treat yourself, or do you see any impurities that we have to treat? Based on all this input, we can further develop the view that we have at the moment and to improve our concept for the specification. So that's about pressure regime and quality.
Thank you, Ronald, for leading us through this, all these technical details. There are a number of questions already that are being asked. Some of them we received already before this webinar, and that makes life sometimes very easy. One of the questions that was asked was the current natural gas system is operated at a higher pressure than the 50 bars that you are currently proposing for hydrogen.
Yeah.
Do you expect also the hydrogen pressure to increase over time to the level that we are currently using for natural gas, or?
Well, it's correct, Gerard, what you said. The natural gas system is operated at higher pressures, up to 80 bar. For the hydrogen system, we foresee a max pressure of 50 bar. Reason for that, based on our analysis so far, is that we think we can create sufficient transportation capacity with that 50 bar, and we think that with such a pressure regime we can provide enough pressure for the customers that will connect to that system. So our view also for the long term is that the 50 bar will be sufficient for the hydrogen system, and we don't need to go up to, let's say, 80 bar.
Another question that was asked is what time frame do you see for the shift from 10 to 30 bar to a 30 to 50 bar pressure regime?
Well, as said, we think we on a small scale, starting with the hydrogen backbone, we will start with a 1030 bar regime. Looking at our scenarios, our transportation scenarios that we see for the coming years, I would expect a shift from the lower pressure regime to the higher pressure regime, the 50-30, around 2030, somewhere about. However, that's for the national system that we see it. It could be the case that regionally that we will have a tailor-made pressure regime that's best suitable for the customers in that region. So it could be the case that we start with a 30-50 regime earlier. It's mainly based on what the market needs. We want to facilitate the market in their pressures.
Another question that was being asked is about quality. We know that especially for fuel cells there's a very high quality requirement. Do you foresee any elements in our system that make it possible to, for instance, directly connect let's say fueling stations to our system that supply the high quality that is required for fuel cells, for instance, in mobility?
That would be the ideal case, if you could connect all different parties and with the highest possible quality so everybody can use it without any treatment. I think realistically a fuel cell spec, which is, let's say, the highest spec you can get for hydrogen, is not realistic looking at a pipeline grade for that's best suitable for the larger part of the market. There are a number of parties that require a lower, can handle a lower quality. So that would mean that we develop a very high spec only to supply a smaller part of the market. So the question is that optimal for the hydrogen market in total? And next to that, if you look at production processes, but also on the transmission system might cause some contamination of the hydrogen flow. So we are not that sure if you would put in that fuel spec quality at the beginning, if you will get it out at the end of the system. So I think besides from is the market asking for a fuel cell spec, I don't think it's technically viable spec.
And the last question, you mentioned already something about quality and pressure swing absorption.
Yeah.
One of the questions was, where do you see quality treatment in the backbone system? Is it part of the Gasunie developments, or is it something that customers should add themselves to the system to get required qualities?
Well, yeah, as shown before, we do see a configuration with PSA units, for example, or safeguarding systems. I would say at the moment we're open-minded with regard to the battery limit. So it could be the case that we develop a PSA unit. Maybe it's more efficient if we would do it on behalf of Gasunie. But it could also be the case that customers want to do it themselves, develop them and operate them themselves. I would say, yeah, we are open to both solutions, whether Gasunie will do it or the customers will do it. In the end, we want to find the best solution for the market.
Okay, Ronald, thank you very much for answering these questions already. As mentioned before, all the questions that are currently being asked will be available on our website, and we will get a link to you to make it possible to read them for you. The next presentation will be on the commercial process that we envisage for the hydrogen developments. Gerrit Noble, commercial advisor at Gasunie, not yet for a long time, but already for some time, I should say. He will explain to you the process that we envisage at this moment for that commercial process. So, Gerrit, please tell us what our plans are.
Thanks, Gerard, for the introduction. Indeed, I've been with Gasunie for 3 months, and it's still great fun. It's been really exciting to join this team at a very exciting time. This morning, what I'm going to introduce is the commercial process, and I'm also going to go into the first stage of the commercial process, the questionnaire, so that you've got the information you require in order to get going. It's going to take about 15 minutes, and I'm sure there'll be some questions afterwards. So, with no further ado, let's get into it. First, on the high level, the envisaged commercial process for the backbone. We're going to start with a market investigation, including a questionnaire. We're going to move through to initial service definition, where we're going to really fine-tune our planned services based on a consistent data set. Then we're going to move through to an expression of interest. This is where we're going to be joining together and looking to commit towards developing our projects further. Not final investment decision, as I'll say later, but to at least there'll be some level of commitment there between us. The next stage will be fine-tuning, and finally commercial terms freeze towards the end of next year. So I'm going to zoom in on each of these steps. Starting with the questionnaire and the market investigation. As Gerard said, we'll be sending out a link to a questionnaire after the presentations today. And we've allowed a couple of weeks to fill in that questionnaire. The idea is not to develop new information, but to provide the information that you already have. And where you don't have that information, an estimate and a bandwidth is fine. But we need to start interpreting the status and interpreting the information that we receive in order to determine what you require. This serves as a basis for tariff indication, for quality and pressure regime definition, and it's also going to serve us for project phasing, deciding when the ribs are going to be developed, when is the backbone going to be developed. After that market investigation, where we'll gather information from the questionnaires, we're going to go into a detailed analysis. Now, we've allowed 4 weeks for this. It's a bit longer than the market investigation for a reason. We anticipate that we're going to need to do some clarification discussions with you. And as we need to do clarification discussions, we'd also appreciate if you can have some flexibility to allow us to plan things in. But it's only this way that we can really lead to an optimal system. Moving on to expression of interest. As I said, the previous items were without a binding commitment from the parties. But with this expression of interest phase, what we're trying to do is, for ourselves, ensure that we've got a view to clients who are moving projects forwards, and also for yourselves to offer the commitment from our side to continue to develop our project. How it works is, based on the service definition, we're going to set up a term sheet including quality, pressure, and tariffs, and phasing, and that will form the basis for your expression of interest. Moving on to fine-tuning. So during the period from 1st of January to the 31st of December 2021, there will be fine-tuning required. We're providing the previous phase only a term sheet. We're going to have to work out detailed agreements between us. These are not on the shelf at the moment. We need to develop these together and make sure it's a fit-for-purpose item. The other thing in this fine-tuning is both yourselves and ourselves will also be looking at what are the government support instruments in order to ensure that we get a robust final investment decision for yourselves and for ourselves. So there's going to be quite a lot of iteration and interaction with the market participants in this phase too. Lastly, commercial terms freeze. Now we anticipate to freeze the commercial terms at the end of next year. In order to do that, we have to have completed FEED, and we have to have a good, robust CapEx estimate, and we all need clear insight into what the instruments are that the government will be using to stimulate the market. So that, in a nutshell, is our process. Now I want to zoom in on that market investigation and the questionnaire, so that you guys can get going with this fairly quickly. Key aspects of the questionnaire. Well, we start with company information. Although it's not binding, it is now part of a more formal process. We've done a lot of interactions up to now with various clients, but now we're trying to get a consistent database, and we also need to have a consistent contact with you. So we're going to ask a little bit of company information. We also want to understand your objectives with hydrogen. Ultimately, we're going to have to make an interpretation of the data we receive in order to be able to optimize the system. And that means that really understanding what you're busy with, what drives your business and your activities, will really help us with that. Then the third part of the questionnaire looks at volumes and capacities. This is we're getting into the nitty-gritty of the material. So we need an assessment of your production phasing over time, and we also need to understand the maturity of your underlying projects. Are you in an assessment phase, a FEED or a concept select, a FEED phase? So please provide us with that information. Now the information you'll provide us, and the information which we in our discourse around this are going to provide to you, will be covered by a non-disclosure agreement. And that's also covered in the link which you'll get today. And this provides sort of a mutual commitment to keep the information contained. It also provides that the information that we do eventually release will be aggregated and anonymized, so that the clients can't be individually identified, and so to keep, if you like, the market process clean. Moving on, pressure regime. Well, my colleagues have explained that indeed we're going to look at pressure regime and quality requirements. Our objective is to have an economically efficient system. And the more information we get in this area, the better. Lastly, in the questionnaire, I want to highlight the ancillary services. Some of the early feedback we've had is that Gasunie is right in the middle of the chain. And so we're well placed to oil the wheels, provide information, and we're very, very keen to fill that role and actually to mobilize the industry in that way. So would appreciate your feedback in that section of the item. It's not the standard dry Gasunie builds a pipe stuff. This is where we start understanding how we can add value to and mobilize the system. And speaking of mobilizing the system, when we set up this system, we're going to try to be provide a flexible system that meets the need of the customers, and we're going to abide by our obligations in terms of being non-discriminatory, transparent, cost-reflective, but maintaining cost recovery. We're going to be economically efficient, and we're going to avoid cross-subsidization across the chain. Our objective is to make sure that this thing flies, and this is going to require a dialogue and indeed a multi-log with a number of parties. So that's what I want to present this morning. I understand there's questions. Gerard's waiting in the wings here to pass them through.
Okay, Gerard, thank you very much for this presentation. Of course, many questions about what will it cost, etc. So the first question, maybe a little bit ahead of everything. Can you give an indication of what transportation costs will be in the new to develop hydrogen transmission system?
Yeah, very, very consciously, we've decided that we will provide costs in 6 weeks' time. To provide an estimate today, and we do have some estimates. Obviously, we've been progressing our project just like anybody else does. But provide it now would lead to confusion. 6 weeks' time, we'll have a number. And this way, I think we can serve the industry. What I would say is the initial cost estimates we've done show the cost of the transportation to be just a small fraction of the commodity price of hydrogen. So if it wasn't, we wouldn't be running a project as it is now.
Okay, thank you. Another question that came up was, I told you already about Highway 27 webinar that we had 2 days ago, the Highway 27 process that's ongoing. Still, there's a lot of uncertainty on how this market will be formed and will be regulated and who will play what role. Are we not yet a little bit ahead of schedule if we already are making these plans now and telling this to the market without having the outcome of the Highway 27 study?
I think that's a very fair question. It was something which struck me when I first arrived 3 months ago. What I've learned here as well is that there is an urgency in the market. And Gasunie is going to make sure we're going to build very safe, reliable, robust systems. There is an urgency which we have to answer. Now, Highway 27 is going to yield its results towards the end of next quarter, the first quarter of 21, indeed the next quarter. And then there's going to be a governmental process whereby the recommendations will be worked through, and I anticipate actually the results will be available about the same time as we're looking to finalise our commercial terms. So the things are not out of phase. We could have done it in series, then we would lose time, and the climate challenge is there now as well. So I think it works.
All right, thank you. A last question for you that came up was, what are you doing to make hydrogen available to smaller customers? We're talking about connecting the industrial areas, We're talking about large shippers, commercial information, people connecting now and answering the questionnaire, but what about the small consumers?
Yeah.
Also because we've learned already that a lot of the let's say the renewable energy studies that are being done by, for instance, different communities, a lot of them say, we want hydrogen.
Sure, absolutely. I think we have to realize that Gasunie's got an important role, but it's not the only player in this. So if I break it down into 3 elements where we're participating to help mobilize this. The first part is the Highway 27 exercise. Gasunie is working together with TenneT to develop for the government a recommendation on the instruments that are required to facilitate the market, not just the large part, but the smaller consumers. The second part is we're going to be developing, and that's our main job, is we're going to be developing a backbone, a system which will transport hydrogen, make it available throughout the country. The third thing is that, and this, I want to emphasize the ancillary services question that we had in the questionnaire. We're going to be looking to see where we can play that role as sort of in the middle of the web and joining parties as well. I don't know how that's going to pan out. I'm very keen to hear what's said in the questionnaire so that we can start giving form to that. But I think these 3 steps will help, certainly mobilizing the small players as well.
Okay, Gerard?
Thank you.
Thank you very much for
Thank you.
sharing your thoughts with us. We will see you back at the end of the next
Yes.
presentation round that we will be having. At this moment, I would like to, let's say, end the first part of this webinar. We will be back in, I think, about 10 minutes from now. I think we should start again at 12 o'clock with the second part of our presentations. That will be about hydrogen storage and all the information about the storage facility that is currently being designed. So therefore, thank you very much until now. And we will see you again in 10 minutes, 12 o'clock exactly. See you then. Thank you very much. Welcome back, everybody, for the second part of this Gasunie webinar on hydrogen infrastructure. As mentioned already in the first part of this, I should almost say show, as it looks like, we're talking about storage. And storage is a very important part in our future hydrogen system. Not only due to the fact that storage is required for balancing the system, but also due to the fact that supply and demand must be matched. And for hydrogen, especially due to the fact that if we're looking towards 2050, towards renewable hydrogen based on solar and wind energy, we will also need to balance the production. We will again have 3 presentations on the hydrogen storage. After each presentation, again, we will lead you through some of the questions that have been asked. And also at the end of the presentations, we will give a wrap-up, and there will be some questions about as well the hydrogen backbone, as well the hydrogen storage facility. But that's the end of this webinar. First, again, as mentioned, we will start with the hydrogen storage presentations. And the first presentation will be on the, let's say, the general part of the hydrogen storage, and that presentation will be given by Inge de Groot, who is project manager of the hydrogen storage facility. Please, Inge, can you lead us through the general topics of the hydrogen storage?
Of course, thank you. Yes, also welcome from my side. It's a pleasure to be standing here in front of you, and it's a pleasure to invite you as well in this process, in this project of hydrogen storage, which we would like to invite you via the questionnaire, which will be available for you after this session. I have a couple of questions which I would like to address in this first part. The first question which I would like to address is the question, why do we need hydrogen storage? We feel that it is essential for achieving the climate goals which have been set for all of us. There are multiple researches already done by different kinds of institutes which look at different scenarios for how to achieve the climate goals. These scenarios also give a large indication about how much hydrogen storage is needed, but we can say that hydrogen storage is needed. If we look, for example, at the future demand and supply, we can already say that it will not match. They will not act simultaneously. Looking at how the current gas market is mentioned, we can see that the production line is a baseload line. This is, of course, in the natural gas market. We can also see that the demand line is very volatile. To capture the flexibility between those lines, we look at flexibility which is in the pipeline, but also the flexibility, a larger part, which can be given by storage. We can see this well working for the future liquid hydrogen market as well. Only perhaps here what we need to see is that the demand will perhaps not be that volatile, but more like a baseload line. This is due to that we think that the industry will be the main driver behind the demand of hydrogen. The production line, in contrast, will be very volatile. This is because the production of renewable energy will increase by wind and by solar. In the end, we can say that balancing is required, and here storage can act as a lung for the future hydrogen markets. Secondly, where and when do we want to develop hydrogen storage? Gasunie already has a subsidiary called Energiestok. Energiestok is located in the northern part of the Netherlands, in the provincie Groningen. Here we have 6 caverns which store natural gas. At this very same location, we also have 4 additional locations to develop 4 additional caverns. In these 4 caverns, we can store hydrogen. Of these 4 caverns, already 1 cavern is leased for around 90%, and which means that we can get this cavern relatively soon available in order for our hydrogen storage. If I'm talking about relatively soon, I'm talking about 2026. We aim for 2026, in which we have our first above-ground installation ready and the underground cavern ready as well for the market. We have, of course, not only this first one, but we have 3 more options, and we want to develop these 3 caverns as well, not only growing ourselves, but also growing with the market, so growing with the hydrogen market. At this very same picture, you can also see here at the top that we have a 1 megawatt electrolyzer. This is opened It's a project which was opened 1.5 years ago by our king, and it gives us a lot of information and experience about how to handle hydrogen. So it's very valuable. And you can see as well that in one of our boreholes we have a testing program, but this we'll mention as well in the technical overview, which will be presented later to you. Finally, there are of course some conditions which are need to be adhered to in every project, so also in our hydrogen storage project. First of all, safety. We have to develop techniques and standards to store hydrogen safely. This is of course very important, and also herefore we have a testing program in place. Secondly, permits. Permits is very of course important for the safety of the project, the timing and the social acceptance of the project. So we will have a lot of extensive attention for this as well. Thirdly, not least, a feasible business case. This is of course not only important for us, but it's also important for the whole value chain. In the end, a liquid hydrogen market should be able to cover the cost and carry the cost of a hydrogen storage, but it might be that there might be additional subsidies needed in order to have a feasible business case. That is a very short and brief overview of the hydrogen storage project, and I can see Gerard's already coming, so I don't know, for some questions.
Inge, thank you very much. Yeah, there were already some questions asked, and as mentioned already before, after this set of presentation we will go through a lot of other questions that have been currently being asked during this webinar. But one of the questions was, what will be the commercial basis for an FID? Is that already been decided on?
No, it's not have been decided on, but here it is important, of course, that the market needs to be able to carry the cost of the hydrogen storage. If this is not the case, I can see also, especially in the first phase of the project, that subsidy is needed, and that will be part of a condition of that commercial FID.
And a second question that was asked, and it's also I think a very logical one, do the development and the backbone and the development of the storage facility depend on each other, and what kind of dependence is there?
Yes, there is a great dependence. So first the backbone needs to be ready in order for us to be ready. We need the backbone to inject the hydrogen in our storage, because we also need hydrogen as a cushion gas in the storage. So there is quite a deep connection between it.
Another question was about the existing gas caverns. You mentioned already we have currently, I think, 6 caverns already in use for natural gas.
Yeah.
Is it also possible to use the existing natural gas caverns for hydrogen in the future?
Yeah, that might be very well possible. I think here we do have to look at when can we use those natural gas caverns for hydrogen, because currently there is still a natural gas market and a very liquid natural gas market. So currently we still need those gas caverns. But in the future, of course, we can certainly look at if we can use those caverns as well.
Okay, thank you very much, Inge, for answering these questions already.
You're welcome.
As mentioned, after the set of presentations, there will be more questions that are being asked that we will be talking about here at this podium. The second presentation on the hydrogen storage will be about the technical issues. Bert Stouwy, technical project manager of the hydrogen storage facility, will be leading you through all the information that he wants to share with you. So Bert, please tell us about the technical information for the hydrogen storage.
Good afternoon, my name is Bert Stouwy, and I'd like to tell you something about the technical aspects of the hydrogen storage, as mentioned by Gerard. What we see here is the existing gas facility plant of Energistock, the subsidy of Gasunie, as Inge has told. This above ground facility is required to inject the gas into the gas caverns and to retrieve the gas from the gas caverns and to send it back to the gas backbone. This facility is in use for our clients to balance the grid, and almost daily we inject the gas and we retrieve the gas, so it's a very flexible, fast cycle unit. And even if you want to do it more times a day, it's possible to do it with this storage. Below this facility because it's built on a huge salt dome in Zuidwinning. Below this facility we have the salt caverns produced, made, built and constructed deep in the salt dome. So that is the really storage, and this is only the above ground facility. As told already also by Enge, we have a small hydrogen unit also available at this location. 2 years ago we started with a hydrogen ambition and reality, and we built this facility. This facility is used by our clients, and they convert their green energy, green electricity, to green hydrogen, and they use it, for example, for mobility, for industry. So that was the first step for us. And our king was the man who opened the facility a year ago, and he was active with the water that day. Another view of the same area is an artist impression. The first one, the first picture, that is an artist impression of the salt dome, is very huge. And in the salt dome you see the purple caverns. You can see that they are very deep in the ground. It's about 1 kilometer deep. So there's a big roof above, so it's very safe to store the gas very deep in the soil. A cavern, a making of a cavern is a combined effort of both Nouryon, who produces the salt, and Gasunie, who uses the empty space to store the gas afterwards. That's the first picture. The second picture, you see again the above ground facilities of Zuidwinning, and every grey square is a connection point of the underground storage with the above ground facility. As Enge already told, we have 6 for the natural gas, of which 1 is very new, it's only a half year old, and 4 positions for the hydrogen storage. The one with a yellow circle, this has a number A8, and that's a special one. It was constructed in the past, but it's not a real cavern, it's only a borehole. Maybe it was a little bit a strange investment, but for a lot of years we have here a borehole up to 1200 meters, and for us it's fantastic because we can use this for testing activities. We have the wish, and we are doing now tests with this borehole. We're buying materials, and those materials will be installed inside the borehole to test with hydrogen. And in case we should have a big cavern, then testing was only able with a lot of hydrogen. But in this situation we can test the equipment with only a small amount of hydrogen. So it's a perfect situation for us. And in the future this one can be used to build a bigger cavern. And with these preparations we will have all the specifications and materials ready, available for making a bigger hydrogen storage in the future. So these are all very perfect preparations. What are we going to build? The idea is to start first with 1 cavern in combination with a relatively small facility for injection and production. The idea is, but of course it's all depending on the market, to have a capacity of 10 tons injection and a little bit more for production. And with a growing market we have to enlarge the facility up to 40 tons per hour injection and production. Every cavern has a size that it can contain about 6,500 tons of hydrogen. That's not the only content, because we also need cushion gas. An empty cavern is not really empty, it still contains 80 bar of cushion gas. So we need a huge amount of hydrogen. To give you a feeling, it looks very small on the picture, but in reality you can store the Eiffel Tower in every cavern. What's very important is that we adapt the storage to the pipeline. And if the pipeline has a regime, a pressure regime between 10 and 30 bar, we also have to adapt the storage to the pressure. And if the pressure is 30 to 50 bar, we have to adapt the storage to that pressure. That's not easy, but we will find a solution to be flexible with that changing regime over the pipeline. Quality is another issue. It's very important that if we retrieve the hydrogen from the pipeline and we send it back, that it is still within the specifications required. And for that reason, hydrogen stored in the gas cavern can become wet because of the water at the bottom of the cavern. So we have to dry it afterwards before we can send it back to the pipeline. And comparable with a gas cavern, it will be a fast cycle storage. It will be possible to change between injection and production within 15 minutes. It's very important, we expect, for the market. A brief overview of the planning, and of course it's all depending on permitting and commercial process. This year we are doing the feasibility study, which we expect to finish at the end of this year. Next year we will start with the basic design and the permitting phase. It takes a lot of time to arrange all the permits. And from 22 we've finished the tests in the cavern and we can proceed with the detailed design and the material supply. In the years after 24 we can start with the construction on site. From 26 it's very important that the backbone has the hydrogen available, because we need the hydrogen to commission the plant and also to do the first fill of the cavern, which is until that moment filled with brine, salt water. And in the meantime, it's very important, we don't have to wait, but in the meantime we have to prepare everything which is required for the upscaling, because a cavern you cannot build it within a few months. It takes a lot of time to produce it with water. So you have to start very early to be able to scale up from the year 27. This is my last sheet, and maybe it's a little bit difficult to see, but this is a combination of reality, the gas production plant of Gasunie, and an artist impression of the hydrogen facility which we intend to build. And our goal is to make everything reality from the end of 26. Thank you very much.
Okay, Bert, thank you very much for giving this presentation. A lot of interesting information, also a lot of nice pictures, already a nice view on how it should develop and how it should look like. One of the questions that comes up, of course, and you mentioned already something about the planning, is will we be ready in time? Can we do this according to the planning that we currently foresee?
Now, of course, a project like this is always challenging. You cannot sleep and wait because time is very important. But we think we have enough time to engineer, to design and to construct everything within the expected and presented timeline. We have an experienced team available, but of course it's very important to have next year everything like capacity and pressures fixed, because that's the basis of our design. So yes, it's possible and we are positive, but there is a lot to do.
A second question that comes up, because it's of course a new development, we're used already to natural gas in the caverns, but how are discussions with the SODM, the State Supervisory of the Mines, with regard to hydrogen storage?
No, we have a lot of discussions with all the authorities and with SODM. We prepared ourselves and them with a lot of meetings to find each other. And one of the first steps was the permit for the A8 test cavern. So that one we already received in May, and we promised each other to keep in contact. So we're positive and the feeling is good, but also for them it's very new. So we have to help each other to grow in the hydrogen situation.
And a last question, a little bit related to that, of course, is if you look at the hydrogen storage facility and the hydrogen development, it's also new from a technical perspective. If we're talking about materials required for hydrogen, which might be different from what we use for natural gas, is it all available? Are developments ongoing?
Now, what we see is that the subsurface, it is very important to meet and to discuss with the producers of the materials, and that's the reason that we planned the A8 test project to test all the materials and to have them available for our new project. And in addition, for the above ground installation, we have to keep in mind that hydrogen is maybe a little bit new for us, but not so new for the market. For example, oil companies do a lot of things with hydrogen. So there is not enough knowledge, but also there is enough to do. So let's go.
Okay, thank you, Bert, for this part of the presentation on the storage facility. The last presentation already for today and the third presentation on the hydrogen storage is about the commercial process that we foresee. Gareth Noble, we've seen him already before, is going to present you what our plans are for the near future with regard to the commercial development of the storage process. So please, Gareth, lead us through your presentation. And after this presentation, we will give a wrap-up of, let's say, both sessions of today. And also we will come back with a lot of the questions that are currently being asked on the different topics. So we are looking forward to answering a lot of the questions already directly after this presentation. So Gareth, please, first on the commercial information.
Thanks very much for the introduction, Gerard. Good afternoon. A lot of what I'm going to present now is very similar to the backbone, though some people have joined us after the backbone presentation, so I'm going to go through it it's still in some detail. And there's also some nuances, some important differences between them, so please do take note as we're going through this. As with the previous presentation, I'm going to explain, first of all, the process which we envisage in the coming time. And I'm also going to zoom in on the first stage of that process, which is the questionnaire, so that you are well placed or well able to answer information and for us to continue the dialogue and enrich it. So with no further ado, let's move forward in this process. So as with the backbone commercial process, we've got the same 5 stages. So we're going to do a market investigation, initial product definition, expressions of interest, fine-tuning of the agreements, and then a commercial terms freeze. So this is very similar, but some of the steps are different. So let's have a look at them and first zoom in on the market investigation. Well, in some ways this is similar. The market investigation, we've got 1st of October to the 14th of October, based on an external questionnaire. There's also the same challenge for parties that some of the information may not yet be available. Well then, in that case, we're asking you to provide the information you have, provide an estimate, even give ranges, but it's the start of a dialogue. The information you provide will be used to get a price indication ready, and we can confirm the injection and withdrawal rates and storage volumes. And it's also going to be the basis for the project phasing for caverns number 1, but 2, 3, and 4 in the time to come. The next step is a product definition. Now, here we start to differ from the backbone presentation. Here we're giving a little bit more time to do this, so we're running from the 15th of October to the 30th of November. We're going to be doing the same detailed analysis of the results of the questionnaire, for instance, to define a standard bundle, if we're going to use standard bundles. But the difference is that we anticipate this is a much more complex picture. It's a picture of the balance between supply and demand projections, which I'll touch on in a moment, and within a market which is substantially less developed as well. So there's going to be a lot more estimation and analysis and understanding. So we're going to need clarification discussions with the clients as we move forward in this phase. Once we've completed that, one step just to further illustrate the complexity of the call-off rates, the withdrawal rates, or injection rates in fact, the maximum stored volumes. It's a complex picture. This is just a compound of 4 different producers, consumer users, and we're anticipating substantially more. If we were to just sum the maximum consumption or takeoff rates and the maximum injection rates, we'd end up with a suboptimal system, or let's call it an expensive system. We're going to try to generate something which is useful, and useful also within a price frame that suits your needs. So moving on to the next stage. So with this first initial product definition, we're going to develop a term sheet and ask our potential clients to commit to progress their projects further. So it's a mutual commitment. On the basis of this, we can also analyze, should we be continuing with the project? I anticipate we will. But it's a mutual commitment to continue our projects through the defined phase or towards front-end engineering design and final investment decision. It's explicitly not a final investment decision. We're not asking the clients to commit at this early phase, but there is an element of reciprocal commitment to proceed. This runs also a longer period than the backbone process, because we've got Christmas in the middle, and because we anticipate it's going to take a little bit longer for parties to really define the extent to which they want to call off on our draft term sheet. Moving onwards, fine-tuning. So this will run from the 31st of January 21 to probably about mid-2022, maybe third quarter 2022. So here we're going to, as far as the commercial side is concerned, we're going to be developing the commercial terms in detail. But we're all going to be doing this within the background, the government's development of its own financial support instruments to make and mobilize their hydrogen market. So this will be a continuing process through that time, and we're going to need a lot of dialogue with participants. We anticipate to freeze the commercial terms at the end of that process, mid-2022, maybe third quarter 2022, which flanges up quite well with the rest of the project. So that was the global process. Let's have a look at the first phase, the questionnaire, and some of the questions that are coming up there. I'll explain some of the background because it's a little bit different as well. So key aspects of the questionnaire. Well, we start with company information because indeed it's a more formal element of the dialogue. We've had lots of contact with potential clients up till now, so we could take the project this far. But now we're entering a formal process, and we need to have good contact with you, so we ask some company information. And we also ask for some information on your projects, on the background to your projects. More than even with the backbone, we're going to need to interpret the data and really understand what the client's needs are and what the purposes are of the use of hydrogen. So this is absolutely key to what we will do with the rest of the data we gather. We also ask, why do you require storage services? Is it in order to meet with seasonal swing of your supplier? Is it to do with instantaneous swing of your supplier? Is it because you've also got shutdown periods of your clients? The next thing we look at is project status, because also in our interpretation of certainly of the phasing, we have to understand when a thing is going to come along. We also need to know how robust things are, again, because we're going to be making assessments of probabilities of success as well. Though we will ensure that we have a system which is up and flexible and able to meet your needs. All of the data that we provide here is going to be covered by a non-disclosure agreement, so that we're both covered and your information is not then individually made publicly available. There is the possibility in the NDA to share aggregated and anonymized data as well. Moving on. We asked for annual volumes, fairly straightforward, over quite a long period, from 25 to 2035. And then the really challenging part we start to address with the offtake patterns. So, and I've split this into two parts. I mean, the first is for those clients which are quite far developed, and certainly there are some with wind profiles and therefore electrolyzer profiles. They can pretty well estimate their even hourly and daily fluctuations. and develop year profiles with that level of granularity. But quite a lot are not that far with their individual projects or with the definition of what the fluctuation will mean. In that case, we're asking for your best estimates. And we will, using the data we gained in the front end of the questionnaire, to start an assessment and also to start a dialogue on what do your assessments mean, or what do your estimates mean. So if a detailed profile isn't available, we'll be asking for an indication: are you a base load, are you a variable load, do you have a maximum rate of entry into the transport system, what is the estimated minimum rate of entry into the transport system, and if you're variable load, will you have a load factor of 0.75, 0.5, less than 0.5? So please give us your best estimate, but then we will start a dialogue associated with that. What I would also like to highlight here is we've split the questionnaire, actually, if you like, the detailed technical information and the company requirements. We've split that into a section for producers, for consumers, and for shippers. In storage, it all comes together. And what we're going to really have to be clear on is making sure that we don't double count. So we actually do split those elements up and ask you to submit your production project in the production element. Consumers can proceed in consumers, and commercial shippers have also got a separate section to submit the data into. Okay, so I think that's what I want to present today in terms of the overall process and the kickoff. I'm very excited about this, and actually also excited about the questions Gerard's going to bring in now.
Okay, Gerard, thank you very much for your second presentation already. The fact that you're on both sides, giving the presentation on the backbone and giving the presentation on the hydrogen stock storage. Can you tell us what's the relation between the backbone and the high stock storage?
Well, obviously they're going to be physically connected, but I think your questions also relates to the organizations. Now, there are two very separate projects under the Gasunie umbrella, but I think there will be two different companies. So we said also that we will make sure that we are not going to cross-subsidize or whatever. These are going to be quite separate organizations. And that's also why we've got separate questionnaires, indeed.
Okay, thank you very much for answering these questions already. That means that at this moment we finished our presentations. It's not yet the end of this webinar. I think that if you look back at what we have learned today, the first part on the backbone, I think it gave us a very good view on what the developments are, what the processes are that we're currently going through, what we see as how the development should go. And I think the same applies to the hydrogen storage. Also there we have told you at least how we look at it and how we look at the development of the storage facility. But I think the second step is it's all up to you, and it's all up to the market, because infrastructure is always helping supply and demand. And therefore we need your information, and that's also the reason that I would like to again mention the questionnaire that we will send to you, together also with the presentations that you've seen today, and that we will send to you very shortly. And we would like to ask you to look at it very seriously and help us in the further development of this project. Now we still have some time left for some questions that came in more or less at the last moment. It will ask some smaller changes to the podium here. Is there an additional microphone? Because we cannot use a handheld microphone that we give over from one to the other. And I have to look at the questions that just came in, and the first questions we will deal with are the questions on the hydrogen backbone. Tom, question for you, Harry, you came up already. How does the backbone fit into the IPCEI on hydrogen? And if so, is it including the Hamburg connection?
As a matter of fact, we submitted proposal for the total of the backbone in the Netherlands last week. So as far as is concerned to us, it fully fits in the IPCEI. It's a startup phase of the IPCEI. Your question on the connection towards Germany and towards Hamburg. Is that working?
A little bit closer to the microphone.
Excuse me. Towards Hamburg, I retrieved some information from my informant in Groningen. It says IPCEI is currently in a development stage, and the Dutch government has organized an open call to gather information on all hydrogen projects.
Sorry.
Okay.
That's always when you're having a kind of live show, then these kind of technical issues occur. So please, Harry,
Okay.
you could start again with your answer.
I'll start all over again then. The question was, does this fit into the IPCEI process? Last week we made our proposal for IPCEI available, and we sent it to the Ministry of Economic Affairs. That is part of the IPCEI that is just starting now. It was also asked whether this fits with an IPCEI, a European IPCEI, for instance, connections towards Hamburg. And I got information from Groningen on this. The IPCEI is in a development stage. The Dutch government has organized an open call to gather information on all hydrogen projects in the Netherlands. And we have submitted information about the projects we are involved in. This includes cross-border opportunities towards Germany. It's up to the member states to determine if they want to be part of the European IPCEI and which projects are needed for that in each country. So that's what I can say about the IPCEI.
Okay, and of course we will have also this answer in the Q&A. There was a second question, which is a little bit more technical probably, but also general. Isn't it smarter to increase the hydrogen content in the natural gas during the transition period instead of making a direct switch from natural gas to hydrogen?
I can make a clear answer to that, and the answer is no. It sounds easy to blend it into natural gas and make it simple. You don't have to split up a separate network. But once you start blending, we think it will be difficult to get back to the usual situation to the situation that we prefer to develop a dedicated network. And when talking about blending, we also sometimes state it's a pity because the hydrogen has much higher intrinsic value than the natural gas. So we say it's throwing caviar in the split pea soup, which you really don't want, I would say.
Okay, Harry, thank you very much for answering these questions. There were also a few questions for Ronald. And one of the questions from Wouter was, when replacing natural gas with hydrogen, what quality limits are introduced due to deposits or other historical contaminations in the piping?
I would say pipeline contamination is actually one of the research programs that we're running at the moment. So it's a fair and a good question. Actually, we don't have a specific answer right now. We are looking at substances that can be present in the pipelines, the natural gas pipelines. We are looking at mechanisms how that contaminations could land in hydrogen. We're looking at ways to clean pipelines. We're looking at technical options to treat the contaminated hydrogen flow. All subjects that we're currently investigating, also interacting with the hydrogen quality, of course, what we told before. And it's very difficult to give a clear answer for now, but it's something we're looking at, for sure. Yeah.
Okay, there was another question. It's a question from Marijn also for you. When you mentioned 99% purity, is this by volume or by weight?
Volume.
And I know it's quite a difference because hydrogen is, of course, one of the lightest molecules.
Exactly.
So the answer is by volume.
By volume.
Okay.
Otherwise, you would end up with a quite different spec.
Okay.
Yeah.
Thank you very much, Ronald. A question for, I think, Gareth, that was asked here. What is the message of Gasunie to smaller industrial clusters in the Netherlands that are interested in hydrogen? And the question was an addition by Cor. I think he comes from the Zaanstreek. Think of, for instance, but there are many more, the larger industries in the Zaanstreek.
Okay. So partially I've addressed that in my answer on the backbone, in that first of all, Gasunie is not the only party who's promoting the use of hydrogen. We have a role. One of the parts is to assess identification of what the needs are in terms of government instruments, and that's the Highway 27. Second element is also to address, provide a system ultimately which will have the reach to those smaller clients. So we're looking not to develop just only the clusters, but to make this broad and make it a national network. And as soon as you've got a national network, then the distances to be covered to reach those smaller clients become smaller. The other message I would like to give, Cor, is that I think it's important to understand that there's a chain here. There are consumers and there are producers, and we are a linchpin. We're looking to see how we can facilitate the connection between those. But it's important as a consumer or small consumer or small producer to start clustering to create a critical mass to allow or to share the costs of connecting into the larger system as well. So I hope that helps. Certainly, we're looking forward to the dialogue also on these kind of points to see where can we help further on this.
Okay, thank you, Gareth. I do understand that really to answer this question in the end we want to have an energy or a hydrogen distribution system that ends up at every household.
Yes.
But it's the process to get there.
Yeah.
Also, some questions on storage, and I have to read them from my phone because that's the way they are brought over to me. A question for Inge. And the question is, aren't there a lot of hydrogen storages needed because of the potential diffuse locations of hydrogen production instead of one hydrogen storage location in Groningen? Can you say something about that?
Yeah, of course. A very good question. I think that really depends on what kind of scenario we are looking at. Is it regional? Is it international? That really depends on where the locations for hydrogen storage needed. I think also from a technical point of view, Groningen is a good location to start. Also with the cavern possibilities we have over there and the salt layer we have over there. But it really depends on how the market is looking at in the future.
Okay, thank you very much for answering this question. The next question here that I have on the list is for Bert Stouwy. And that question is, for the expected demand, have you made a comparison between the costs of cavern storages and above ground storages?
Yeah, you can talk about costs, but maybe more important is to compare what's possible. If you, for example, take one cavern that has a size of 1 million cubic meter, that's for us a normal size, and you store the hydrogen with 200 bar, and you build the same above ground, you need a cube of 100 meters. So it's very complex to build a cube of 100 meters strong enough to store 200 bar of hydrogen. And of course you can say lower the pressure, but if you lower the pressure, the size will be bigger. So if you calculate, it's almost impossible to build a huge storage somewhere above ground.
I think that's also quite a connection to one of the other questions. Cor asked, is underground storage also possible in other areas in the Netherlands? For instance, at locations where wind from the sea is coming and where hydrogen is being produced?
Of course, I don't know all the details about the soil in the Netherlands, but the only thing I know is in Zuidwinning we have the salt dome. That's very good to make a cavern. And of course, maybe you can store it in depleted gas fields, but those are other discussions. But yeah, maybe everywhere where there is a salt dome, you can make caverns like this. But the big advantage is that we have the cavern close to the backbone, and we have the knowledge and we have the organization. And it's very important to merge all those things, and also to use the same organization which we use for the gas storage, to use also for the hydrogen storage. And in that case, we can minimize additional costs. So for us, it's a perfect solution here.
Okay, and maybe a more or less connecting question from Tonius. What is the approximate amount of cushion gas that you need for cavern storage?
Yeah. It depends on the depth. The deeper you are, the higher the pressure of the earth. But an estimate that it's about between a third and a half of the amount of working gas. So it's a huge amount, but you need it to have an empty cavern.
Okay, thank you very much. There was a last question which was more or less addressed to me, which is about the hydrogen market that is envisaged. Maybe, and I think that many of you will have read the press announcement of the, let's say, the hydrogen, let's say, market system that we are currently developing. What we all know, of course, is that the Netherlands will be perfectly suitable for the production and storage of hydrogen in the near future. The connection that there is between a lot of offshore wind possibilities, maybe also for liquid hydrogen to be transported to our harbors like the Rotterdam or the Groningen or Amsterdam area. And the big question will be, of course, then will there be some kind of TTF for hydrogen? And I think the answer is quite simple. Yes, there will be a kind of TTF for hydrogen being developed. What we yesterday announced was that Bert ten Ouden, previous director of APX, is going to do, let's say, the follow-up of the study that we are doing on that subject. And I also think that it is very important to have such a, let's say, market system like TTF for hydrogen, because that's a very good way to stimulate the market development. To get the value for the hydrogen, to get the value for the green hydrogen, and also to make it possible for users in different areas to get access to that hydrogen. So yes, our expectation is that TTF for hydrogen will certainly come and probably and hopefully also quite soon. That brings us to the end of this webinar. I hope that it was a very interesting webinar for you. I hope you've learned a lot. I hope that this webinar is also the start for a very good discussion that we will have with many of you. As mentioned already quite some times, is that for us, this is the basis for a discussion that we want to have with you, based also on the questionnaire and the answers to the questionnaire that you give. I also mentioned already that normally we would have come to you, we would have liked to have that discussion with you. Due to the circumstances that we have at this moment, this wasn't possible. It has another advantage. You might be sure that everybody has the same information at this moment that we have shared with you. There is a possibility to watch it back. So for those who have not yet have seen this, they will be able to see it anyway. As mentioned also, we will send an email to you with a link with answers to all the questions that have been asked during this webinar. And also, and again, it's mentioned many times before, please fill in the questionnaire. Please make that contact with us so we can continue this process together with you and also based on your information. Again, thank you very much for your attention. This is the end of the webinar on hydrogen infrastructure. On behalf of all the participants and Gasunie, thank you very much for being with us on this webinar. Thank you and goodbye.